Alright, so basically last night, as you guys were working on your document, probably read through the website, and maybe some of you guys felt comfortable enough, you already knew what some of the definitions were. And we'll be looking at a little bit more detail today. We'll be calling on some of you guys to share ideas where you found the pictures that represented some of our terms. But first I want to go to our objectives for today. They're fairly straightforward. Basically, we need to learn how to differentiate between a line, ray, and a segment. And then we're going to learn how to label those things. For a lot of you, this could be a very confusing course because of the way that we label things. We use a lot of letters. And unlike in algebra where you have the single letter variable, in geometry, our variable is often a word or 2 or 3 letters. So that's something that's kind of difficult for us to understand. So we need to learn how to correctly label those and learn how to speak the language. How many of you guys are currently taking a foreign language class? Or how many of you guys have previously taken a foreign language? I've done any. I thought we would have more. Okay. When you guys took a foreign language, was it easy for you or was it a little difficult? A little difficult? All right. Why? Listen. Yeah, is you really got to treat the mind and basically really have to get that mind to be on that whole wavelength the entire time. So this is going to be the same thing in geometry. You're really learning a foreign language for a lot of you. We write things differently, we say things differently, so it takes a little bit of time. Jackson? Amen. It's your nose. Do what you want.
Speeding on phone.
And then the last one there, I honestly, I hope I don't offend anyone with this. When I first taught high school and I teach geometry, I never thought in a million years I would have to actually differentiate between perimeter and area. Well, over the years, I've quickly learned that students don't know the difference between the two. And we often forget which one's which by the time you're 15 and 16, I'm a little bit confused as to why that's true. So we're going to talk about that today. So the first thing I want to go over are these basic definitions of point, line, and plane. Who can give me their definition of a point? Oh, good, Sarah.
A point is any dot in like an area or like a plane, like a little dot.
So any dots. So any, oh, that's a little thick. So any dot in a plane, Sarah, is that what you said?
Yeah, like on a line or a plane.
Any dot, also like any clot. Any dot on a line or plane. Yeah. So is this a point?
Yeah.
Is this a point? Is this a point?
Mm-hmm.
So how do we really define a point? That's a pretty good start. I like that. Is any dot on a line or plane? We're going to go a little bit deeper now. Yes, when we start talking about dimensions, there's a flow here to our dimensions. And a point has 0 dimensions. Okay, that's kind of important to mention. So it has no dimension. So there's no pre-prescribed width or length or depth. It just is. For those of you guys who like to study astrophysics, you can almost think of this as a singularity. singularity in point or in space. It just is. And you can take just a microscopic movement one way or another, you're at a whole different point. So that's really what a point is. So it basically, so when you talk about any dot on a line or plane, what does that dot represent?
Like a spot.
Yeah, okay, that represents a spot. It basically represents a
Like
location. Okay, and that's really important to understand. Points represent locations. And again, it has no dimensions. Okay, what about a line? Definition for a line. Okay, guys, think about it. You guys graded your definitions last night. What are the definitions you guys came up with for a line?
Wait, I want to answer
Hey, I'm waiting. Mackenzie.
It has only one dimension, which is length.
Okay, so it has one dimension. Well, what is a good definition? Jackson?
It connects 2 points using the shortest path.
Ah, perfect. A line connects any 2 points. So a line connects any 2 points. Just like Jack said, it's going to be the shortest path, so we're not going around corners trying to get there. Connects any 2 points. So we need 2 points to make a line, correct? If I have just 1 point, I can't make a line. I need to have at least 2 points to make a line. I'm going to offer a mind stretcher for the moment. Assuming I can draw straight, which I can't, we would call that a line, correct?
Mm-hmm.
But yet, if I come up here, and you're sitting really close to the board, whoops, you can actually see the pixels on the projector, the actual individual pixels. And each one of those individual pixels represents a point. So when you're really looking at a solid line, what is it really? It's a bunch of points together. It's an infinite number of points. Okay. Think about pointed. There's pointillism. Pointillism is an art form. You guys heard of that before? No.
What did you say?
Pointism. Chris?
The one where they like draw drawings by putting dots.
Yeah, it's a single dot. And then so they're up there, and they're literally just taking their paintbrush. They're not brushing with large strokes. It's just a dot. They're literally just dotting it. Okay. And then when you step back, you actually see the entire image as it's supposed to be. But up close, you see all the individual dots. Okay, it's kind of like the mosaic images that we have now. A lot of times we're taking movies, you'll take a character out of the movie, and that image of that character is actually a mosaic of all the scenes from the movie. You guys seen that before? Like I think the one that always pops in my mind is this picture of Yoda with a bunch of the Star Wars images, scenes. And probably there's definitely one I know. I've seen one of Homer from The Simpsons, right? Okay. But it's actually, your TV works exactly the same way. What we see is a solid image. It's actually a whole bunch of pixels in red, blue, and green, the RGB. Okay? You ever heard that before? Notice on your TV when you go into settings, RGB. Every pixel is a setting of RGB, of a red, green, and blue, and they're given different values. And depending on how I adjust the red, the green, and the blue, I get different colors for that single pixel. One single point. But yet, when I step back and I look at the TV as a whole image, that's when I see the full image. But if you get close enough, you can see the individual points. And a line is very similar to that. It's just a collection of points. Infinite number of points. Something to think about. The difference. What do you guys come up with?